Hello there, and welcome to another session of coding some visual effects on the PICO-8. I was thinking about the format of the show after last week's stream, and I was thinking that I'm going to try something like where every time I'm going to start by doing some larger, covering some larger topic, and then if I have time after that, then just improvising. So I'm going to do that tonight, and tonight we're going to, well, last time we did a wireframe cube. We're going to build from that, and we're actually going to do a polygon filler for our cube. You may notice that I've taken the liberty of doing to start with some of the functions we did last time. If you didn't see last time's show, I'm just gonna go over this quickly. So here's the mathematics we need for both 3D and 2D rotations. Here is a function that flattens a three-dimensional point to a two-dimensional point. Here's a rounding function. Here's a dithering patterns, and here are vertices for a cube. We're going to be starting with that. But let's go over the how the rendering pipeline that we're going to do, how it works. Oh, and also check out these links. I'm going to post them in the chat. These have been really helpful to me when I figured this stuff out. Here's a short description that a description of that Mateusz Mortatti, I hope I pronounced that right, wrote about his own 3D rendering system in PICO-8, and here's a document about triangle rasterization. I'm gonna copy both of these links into the chat so you can get them from there. Just a second. No, why did that not? There's one of the links, and wait a second. There's the other one. So yeah, let's describe the steps that we're gonna take. First, we need to define our 3D object in space, transform it in world space, that is rotate and translate it, and then transform it to camera space, i.e. move it according to where our camera is, and flatten the points. We did these last time, but this time we're going to need a render queue, because we need to determine the order in which we draw triangles. But yeah, let's start with defining the cube. As you can see, here are the base vertices. Now, this time we are going to. Last time we defined our object with lines. This time we are going to define it from triangles, and it's going to be important that we define the triangles in clockwise order. You'll know why later on. But yes, let's base tries. So let's start with the backface. So these vertices 1, 2, 3, 4 are the vertices on the back. These vertices 5, 6, 7, 8 are on the front. So these have to be in, well, because these all need to be in clockwise order, that means the backface needs to be in counterclockwise order. So it will be clockwise order when the thing rotates. So this is our back face, and our front face is of course going to be Then the faces, the other faces, the top face is going to be, it's gonna be, I don't even remember which was top, was it minus or plus? Let's hope it was minus. So yeah, so that would mean, yeah, maybe I should have defined this earlier as well. So front 5 and 1 and 3 and 3 and 6 and 5. That's our top face. Our bottom face is going to be 7. Wait a second. 7 and sorry, I'm 7 and 3 and no wait, of course 7 and 3 and oh yeah, this of course needs to be 2. I'm just messing up already, sorry about this. And this is gonna be some riveting entertainment right here. But okay, let's just define these and fix them later on if I messed them up. And okay, so this is going to be the top face, and the left face is going to be 1 and 1 and 4 and a second 8 and 8 and 8 and wait a second. 1 and oh yeah, obviously, yeah, sorry, it's gonna have to be 1 and then the next is gonna be, sorry about this, I didn't prepare this as well as I should have, so it's gonna be 1 and 5 and 8, then 8 and 4 and 1, I think. That's the left face. So then the right face is going to be 2. I mean, the one of the triangles from the left face, and this is going to be. No, wait. Of course, I was. Yeah, both of the triangles. Yeah, sorry. And so the right face is going to be 2 and 2 and 2 and 3 and 7 and wait a second. So it needs to be 7 and 6 and 2. Now let's see if someone on the chat has already said that I've defined this wrong. Apparently not. So these are our triangles as references to vertex indices. So let's see if we've done this right so far. So let's do a draw cube function. And we're gonna do it by for try in all base tries do and we're gonna define an array for our triangle vertices and let's see what was add the new and base try vertices try I think, and there, do this right, and then we add our new triangle to the sorry, I'm kind of getting confused about what I'm trying to do here. Okay, so we need, because these base tries are references to here, so we don't do anything with them. We need to add to the triangle oh yeah, we don't need this, so obviously we're just gonna add them here, so then we should have our three-dimensional triangle vertices in array V now. Then we're gonna flatten all the points. And we have an array called vFlat where we add our flattened points, and I'm just gonna have to see what the syntax for my flattened point function was. So add vFlat, a flattened point, v1, v2, v3. So now we should have three flattened points. Let's see if we did this right. And from point 1 to 2, from point 2 to point 3, and from point 3 again to point 1. Yes, and of course we're gonna need to translate the z value of all of the 3D vertices to get it, to move it away from the camera. So let's see what happens now. Nothing happens. Why is that? Why? Oh, I was supposed to. Oh yeah, of course, because I need to because the B is a larger. Okay, folks in the chat, what have I done wrong actually? Help me out here. I do have a cheat sheet if I can't figure it out, but I'd like to remember. Yeah, this is not going well so far. Good point, Serix. I am not calling it. Okay, now we're getting somewhere. We have a so now we can do this. Yep. And now we need this, and of course the one there that I just put in the for loop above it needs to be I. So let's see if it works now. Okay. Yes, of course it's not supposed to do. Yeah, I mean, I need to redefine these in the draw loop, obviously. So let's see now. Yes, now we have a cube that, and we notice that we have in fact misdefined it. So let's think about this again. Let's think about the vertices that we need. Let's just define this one vertex, one side at a time. So yes, now we know that the backface is messed up. So obviously it is because. So 1, 3, and 4, and then it needs to go to form 4 and 2 and 1. Why? What have I done wrong this time? Because the... Let's start with one of the triangles. It's a good thing I reserved a bunch of time for this, because I have actually no idea what I've messed up now. So that's the triangle from 1 to 3 and 4. Now the triangle from 4 to 2 to 1 should be... By subtracting it... Oh yes, yeah, I'm subtracting it, the z-value, every time it draws a triangle. So what I need to do is do these transformations before this whole loop. Yes, obviously. There. Thank you. So for try in all base, no, for vert actually, for vert in all base try vertices, do vert 3, and now we should have a triangle that works, I think. Yes, we've still defined this in the wrong... Let's see now. Are these correct? So 1, 2, 3 is that triangle, yeah? And 4, 2... So I'm actually kind of mystified here because 1, 3. Why is that now not a rectangle? So this is one corner, minus 1, minus 1. This is 1 and 1. And this is my... Okay, so this should be the top left corner, top right corner, bottom right corner, and bottom left corner. 3. Oh yes, thank you. I'm feeling so incompetent here. I do wonder if that is now counterclockwise, but we'll see. Okay, so let's continue with the front face. So it's gonna be the vertices 5, 6, 7, 8 are gonna be the front face vertices. So let's see what happens now. And then 7, 8, 5. Okay. Then we should let's move this for a while and let's do the side vertices. So left side should be vertices 1, 4, 5 and 8. So in clockwise order, 1 and 5 and 8 and 8 and 4 and 1. Is that correct? Yes. And then the right side should be all the other vertices, so 2, 3 and 6 and 7. So 2 and 3 and 6 and 6 and no wait, 7 and 7 and 6 and 2. Is that right? Yeah. And now the bottom vertices, they're gonna be 1, 2, 5 and 6. So starting with the front face, no, actually starting with the back face, it's going to be 1, 5, 6 and 6 to 1. Oh, I forgot a comma. And that's actually the top face, so we already know that it's not gonna be clockwise. So let's change the order. Wait a second, 1, 2, 6. Yeah, and then the bottom face, which is the other, so 3 and 4 and 7 and 8. So starting with the back face, it's going to be 3 and 7 and 8 and 8 and 4 and 3. Yes. And now we're just gonna hope that these are all in clockwise order. We'll see that later on. But yes, now we know that we at least have a cube. We can, I guess we can also rotate it. So let's take this rotation matrix here. Let's copy it so we can have it for reference. So before that camera translation will rotate it around the y-axis. So forward in all base driver vertices do. So how did we do this last time? So x new, it's going to be just vert 1. Oh yeah, we actually need to do this with as a for loop without the using the or, because the arrays are just references. So we need to do it kind of like in a different way for this to work. For I is 1 to the size of base try vertices. Do new x equals base try vertices 1, because it won't. No, wait, we're rotating around the y-axis, so it needs to be that times cosine theta. We're going to define theta later, plus the z plus z times sine theta, and y is just gonna be y, and z is gonna be minus x times sine theta plus z times cosine theta. And oh yeah, and of course, yeah, I forgot the eyes here, because of course we need to, that's the structure of our array. And then this entry in the array is gonna be, if we say new x, comma new y, comma new z. Let's see if that works. Oh yeah, and I forgot to define theta. So theta is frame times, let's say, yes, and now we have a rotating cube. So next, let's try to fill our triangles, and this is where it's gonna get a bit more complicated. Let's forget our cube for a while and just focus on doing a filled triangle. And our filled triangle is going to take an array with 3 two-dimensional points as the input. And so let's just start by just drawing a non-filled triangle. So from point 1 to point 2, and from point 2 to point 3. And then from point 3 back to point 1. And let's call our try-fill function. Let's do it like, let's say we do a triangle from, these are our screen coordinates, so let's say one corner is 20 and 20, one corner is 80 and 50, and one corner is 70 and 100. So let's see if we did that right. We did not do that right because there's a square bracket for some reason. Okay, so now we have one triangle. Now we need to fill it, and this is something that doesn't exist in PICO-8. We need to do it by ourselves. So I had put the notes about triangle rasterization and also insertion sort, because we're going to need to do sorting to do this. Again, sorting is something that doesn't exist in PICO-8 by itself. We'll need to implement that by ourselves. So, first of all, we'll need to find which of the vertices is the middle vertex, and we do that by just sorting them. So let's do our insertion sort loop, which we have defined here. First we declare that I equals 1, and well, this loop is gonna go to the 3, because that's going to be the size of try 2D. And then at the start of each iteration, we declare that j, which is our another iteration counter, is equal to I. Then we do a while loop. While j is greater than 1, which it's not going to be at all in the first iteration, and our sorting criteria, which is going to be y, or the second entry in the array index. So while j is greater than 1 and try to the j minus 1, 2 is greater than try to the j2. Now wait a second, did I use a do in while? Let's see, while. Yeah, it's a do. So while these are true, we swap the two entries like that, and we decrease j by 1. And we are doing this until the entire list has been iterated. So now we should know the y value of the middle vertex. Let's see if that is true. So we're going to draw a line from 0 and the y value of the middle vertex to 127, and I get the same y value. And 7. So now we should have a line that looks like nil from. Wait a second. what is it now? It looks like I have a... What's going on? I have it looks like it's interpreting some of these things here as instructions. I don't know why it's doing that. Oh yeah, and I'm missing a do here. Let's see if it's because of that. Yes, it was because of that. So now to test if the sort is actually working, because that was the second vertex. Anyway, we'll swap the places of these two vertices. And now we know that we know which of these is the middle vertex. Yes, I'm gonna need to check the chat every time I mess something up, because I'm the sloppiest coder on Earth. But yes, now we can split the triangle into two flat-based triangles, because now we can determine the point on the opposite side of that corner, and then where it intersects with the line we have just drawn. We do it with here's how we do it. I posted a link to this sunshine2k.de article earlier, so the maths behind this, if you're interested, they're described there in more detail. So this is going to be like our fourth vertex of the triangle, kinda. So try to D, and the x of that fourth vertex is going to be the x will be like this. So and y3 minus y1 and x3 minus x1. Did I fill that incorrectly? I seem to have filled it incorrectly. Yes, that is the x, and of course the y is just going to be the y of the second vertex. So let's see if we did that correctly. So now we should draw a line from vertex 2 to vertex 4, and that should cut the triangle into two flat-based triangles. I tend to index them. Okay. So this is strange. So try to D. That should. Oh yeah, we forgot the curly braces, obviously. So it was just trying to. Yeah, now it adds it as an array. Yes, now it works. And now we can start doing the rasterizing, i.e. filling, because it's pretty easy to fill a flat-based triangle. And so we're gonna do another function for this. We're gonna call it flat tri-fill, and the arguments this is going to take are two-dimensional points, then the x value of the fourth vertex we just created, and a direction value. Now we'll start by defining the scan line that's going to draw this. So we're going to start at the edge. So we're defining two x variables and a y variable. Every time it does a pass, it's going to draw a line on y between those x values. So all of them are just going to be the edge that we're starting from. So scan x1, scan x2, and scan y, they're going to be xa and xa and ya. Now we can calculate the slope of the two sides. We're just gonna copy this here because we've already spent a lot of time. That's how we calculate the slope of the other sides. And now we can do a for loop for... No, wait, we don't actually have to... Of course we're not defining the scan y here. For scan, because it's just going to start at xy. For scan y we're going to start at xa. We're going to ya obviously. We're going to go towards yb, and we're going to increment it by direction, because when we're drawing the bottom triangle, that's going to be -1. Now we're going to do line scan x, one scan y, scan x2, scan y, 7, and we're going to increment both of the scan x values by our slopes. So scan x1 and x2 is going to be also incremented by the slope. So now we're going to and do calls to flat tri-fill to our tri-fill function. So let's start with the top. So that's going to be our xa and ya are going to be the y and x and y of the first vertex, and the y and the xb and yb are going to be the x and y of the second vertex, and our xc is going to be the x of the fourth vertex. And direction is going to be +1. Did we do this right? We did not do this right because we're missing a do. Okay, so let's see if that works. Okay, thanks, Weebleball. I'm going to try to be a bit more sharp. Okay, so now we have the top of the triangle. So just to illustrate this, we're going to add a flip after each call of a line. So basically that's gonna force a frame buffer update after each line call. So now we should see it drawing the line. Yes. So it does it like that. Now great, that worked. And we can just do the bottom triangle, so it's gonna go from vertex 2 to again, vertex 3 to again vertex 2, and this time it's going to go in direction -1. So did we do everything right? Okay, now we have a triangle filling function. So now we should be able to implement this in our cube drawing function. So let's remove these and try fill. So the first, so B flat 1, B 1 1 the X, and B flat 1 2 the Y, and then 2 and 3, 2 and 3, and no wait, and did we do that correctly? Let's see. Yes, we have a rotating cube. Now we're going to want to have it not be quite that monocolored, so let's add materials to it. And for now on, the materials are just going to be colors. So let's do another array, and now we're going to we have 12 triangles, so they're all going to be color 8 and 9. And okay, so now what can we do with that? So now we'll remove this color definition here. Instead, we're going to define color before we call the triangle filling function. So color base, oh yeah, now we need to do things a bit differently. So we're going to we need the number of the triangle, and one way to do it is we won't use all, but we're gonna use pairs. So now pairs should be K should be the number of the triangle that we're drawing. Okay, so now if this works, we should have 2 colors, but the cube should still look a bit weird. And let's see if that works. Yes, it works, but now you notice that it kind of looks weird. That's because we are not sorting the triangles properly. We need to do that so that it will, because it needs to draw the back triangles first. In a more advanced, if we had more processing power, we would do this with a Z buffer, which basically stores the on every pixel the depth of the closest pixel drawn in that pixel, if that made any sense. But that is quite costly. We're not going to be able to do that on PICO-8, so we're going to implement something called a painter's algorithm. So let's do that. So our steps for the rendering engine are as such, and we're going to sort them. We're going to be using the highest Z value, that is the closest to the camera of each of the triangles. So we're going to need to, yes, so this, now we're going to define another array. We're going to be calling it the render queue. So now, instead of doing this right away, instead of doing this right away, we're going to be adding all the triangles as two-dimensional triangles into our render queue. So let's define a new array called new render queue triangle. So first things that we are adding to this new array are indeed the two-dimensional triangle vertices. Like that. They're going to be the first things we add there. Then we're going to add the depth. So we're going to define our starting depth as -1000, and now when it adds the base vertices to the V array, we're gonna do this. Depth is max depth and VI3. So now it checks if the Z value of the currently newly added vertex is greater than depth, and if so, it's going to change depth into that. So we're going to add this depth variable to our new triangle array. And finally, we're going to add the material to this new array. So and now we have this array, we can add that to our render queue. Next thing, after we've gone through all of that, we're going to be calling another function that we're going to be calling render queue. Now, let's define that function. So at this point we're going to be sorting. Where did we have that sorting algorithm again? Where did I put it? Where did I put it? I put it somewhere here in the trifle. We can use pretty much this same code here with some variations. So of course we're going to be sorting RQ and instead of try 2D, and let's see, and the sorting criteria is going to be index 4, which is our depth value. Now we should have a sorted rendering queue. So now we should be able to add this code here again with some variations. So for try in all of render queue do, and the color is going to be value 5, and now this try fill thing here can be a bit simplified. We can just add the whole triangle array here, because our triangle filling function is only going to be using the first 3 values of it anyway. Let's see if that worked. Attempting to index field. Okay, so we did something wrong again. Let's see now. Okay. Oh, did we actually? Yes, we did flatten the points, so what is actually wrong here? Strange. Let's see first if it gives us an error message when we do this. It doesn't, so let's see. Set pset try 1 1, and now we should have 1 vertex from each of the triangles, which we do, but we are missing one of the vertices, and I wonder why. I'm guessing this probably is the reason it fails with one of the triangles. So let's, for debugging's sake, let's do this. For I equals to 12, no, actually 11, because we know we have 12 triangles. So now we can test the theory if it's the last triangle that is causing problems. And Let's actually remove the sorting now. And I think I know. This is probably a variable scope problem. Let's try putting this RQ equals thing in the draw loop instead and see if that helps. No, it doesn't. What the heck? Let's try actually passing the runner queue as an argument. What? What is the issue here? I have no idea what's going on. So the RQ should have 3 vertices. So this. Okay. Now, what is the issue here? So, do we for some reason have to do it like this? So let's do it the hard way. This is probably the worst coding stream on Twitch ever. Okay, now it works. I have no idea why I needed to do that, because it should have worked in my own 3D routines. It works exactly like that, but it doesn't for some reason work like that here. But let's just, now it seems to work. And now we should be able to, oh yes, and we need to re-implement our sorting algorithm here. And yes. Now what's the issue? I'm pretty sure I'm sorting them correctly. But it's not sorting them correctly. So what's the issue? Now wait, what's this 4 here? It's supposed to be 3 because we're using Z. No, wait, actually we are using 4 because it's the depth. So, am I defining the depth all wrong? Let's do it like this instead. So minus was away from the camera. So we can try doing it this way instead. Now let's see if we are solving them correctly. Now, we still have some weirdness in one of the triangles. I'm not sure what's going on there, but now we have a glitchy but kind of working painter's algorithm here going on, and but let's move on because we're running out of time. We're just gonna have to live with these glitches. So I'm going to try to implement shading, and as you can see, we have our colors defined here already. So let's use those. So now we're going to be using materials. These materials instead. So that should now be 2, 4, 6, 10, 12. So now we're going to need the normals of the triangles. And for that, oh yes, calculate normal. So we're gonna need to, let's see, in which points should we do this? We should do this probably here. Yeah, virtual hugs to you, Alcama. I'm doing great, except this stream is a complete mess, but otherwise I'm doing fine. Thank you. So, and let's see now. So, let's take our notes here. So, and let's make it sure that they are comments. So, first we need to get vectors of 2 of the sides. So side 2 minus 1 and side 3 minus 1. So vector A is going to be actually, we probably should do it at this point. Yes, we should do it at this point. So vector A is going to be V1 1 minus, no, V2 1 minus V1 1 and that's the X, and then the Y and the Z. That's our first vector, And now the second vector is going to be 3, vertex 3 minus vertex 1. Now we can do the cross product, and we're gonna do it with like this, as we see here. So the cross product of these two sides, and this is why it's important for them to be clockwise, because this is going to define the normal of the triangle, as in the face in which it is of the surface. But if these are counterclockwise, then this normal is going to point the other way. But let's see if they are all counterclockwise. So cross product equals, so S1 is going to be I'm going to copy this here so it's going to be closer to my eyes. So yeah, it's going to be the second, it's going to be the y of vector A times z of vector B, minus z of vector 3 times y of vector B. Okay? And actually, why do I have curly braces here? Because these are numbers and not arrays. Then the y of the cross product is going to be the z of vector A and the x times the x of vector B minus x of vector A times z of vector B and then the z is going to be the x of vector minus okay. If I did not mess anything up, we should now have a cross product, and we're going to need to normalize it. So we're going to have to, so it's going to, the length is going to be the square root of the sum of the squares of all the components. So we copy this here, and yeah, that should be the length, I think. And now oh yeah, of course we need to again do it like this. Now we should have, now that cross product should actually be the normal, and now we can use that for our shading. So let's add that to the render queue. And since we're going to have a directional light and our only light source is going to be at the same point as the camera, so we're only going to be needing the z value of the of the normal. Which means that we don't actually have to do this 3 times. Okay. Now let's see if I've done any. Okay. It runs, of course, now it uses 0 and 1 as the colors, but now we should have the normal there. And let's test if they're facing the right way. So, let's see, color 0, so normally it's gonna be black, and now if the normal is greater than 0, then it should draw it as white. Yeah. Oh yeah, then let's see if everything's correct. Yes, many of the triangles seem to be correctly defined. So that's better than I expected, to be honest. Now we have the normals for our triangles. So now we're gonna get to use these. So we're gonna define our color from the pixels in the sprite sheet, and we're gonna be using that using the function sget. So sget x, y is gonna return the color of the pixel with that coordinate from the sprite map. So now it should draw everything as red. Let's see. Yes. And now we can actually use the material value to change the y. So that was 5. And now we should have red and yellow triangles. Yes, we do. And let's actually do so. So let's have our base brightness as 0, and now this black square here is going to be the base value of when there's no light. It's going to be drawing that. So that's going to be the pixel 3. Now if I did that right, we shouldn't see anything, and we're not seeing anything. Now let's add the z value of the normal to our brightness. And so that's RQI6. Now let's multiply it by 4, and now let's make sure it's between 0 and 3. So let's clamp it to 0 and 3, and let's make sure it's going to be an integer. So now we should have something resembling shading here. Yes, we have something resembling shading here. It doesn't work for some of the triangles because they're not, I think because they're not clockwise. So let's try to fix that. So let's see. These are the okay, I'm gonna put it spinning there so you can have something to look at while I'm figuring out this mess. So this is supposed to be the left side, I think, yes. So left, so that's from 1 to 5. So it comes towards the camera and it goes down. Yes, that should be clockwise, as should be this. Now this is the right side. That starts away from the camera and then it goes downwards and then it comes towards the camera. So I think, yeah, this is probably counterclockwise. Let's see. No, it's even worse. You know what? I think we're going to just fix these. Change these one at a time and see if they're fixing anything. Oh yeah, no, so 156 and 621. Let's see if that fixes anything or breaks anything. That doesn't seem to fix or break anything, but that's because it's the top or bottom face, so we're not even seeing that right now. So let's try to fix this instead. No? So let's try to fix this. No, it's even worse. What did I do now? I messed up something here. Oh yeah, 3 minus brightness. So what is that one triangle that is wrong? Actually, we can hunt it by just making the whole cube red and then... Wait a second, is that now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we should have 12 red triangles. Now let's start changing these to yellow until we find our culprit. So, it looks like triangle 1 is misdefined. Yes, very much. Correct. Now we have at least 8 clockwise faces. Let's do another rotation, let's say around x-axis, so we should be able to see all of the faces. So, rotation around x-axis, we're going to copy this to help us, and so x is just going to be x. Y is going to be y times cosine theta minus z times sine theta, and z is going to be y times sine theta plus z times cosine theta. So now it should be spinning around 2 axes. What? Unexpected symbol. Oh yeah. Okay, so now we know that one of our faces is misdefined. So let's actually 2 of our triangles. So again, let's change this. It should be these last 4. 1 0 1 0 1 0 1 0 1 0 1 0 0 1 0 1 0 1 0 1 0 0 0 0. So now our top and bottom should be red. Okay, now let's start finding the culprit. Okay, if this is at least misdefined, did I do 0 1 0 1 1 0 1 red? So it looks like this is also misdefined. No, what? Okay. Is that it? I am quite mystified now. Because what's going on? Okay, I have no. Now they're all broken, so now the issue should be changing them all. Okay, now they are properly defined, I think. Okay, yeah, I should be looking at the chat. But yeah, now it looks correct. How much time do we have? Oh, I was hoping to do shading to it as well, like more smoother shading, which we could have used our dithering patterns here for. Unfortunately, we are kind of running out of time. This didn't go as well as I had hoped, and I'm gonna promise to prepare a bit better for the next time. But now we have a mostly functional polygon filler. It still it features a simple painter's algorithm, which is not perfect. It can run into issues in certain cases. For example, if you go on YouTube and see my demo, progressionization, it has some 3D objects in it. One of them is a table, and you'll see an example case where a painter algorithm doesn't work because just the depth values were not enough to, like, if you have really long triangles in one direction, it might have difficulty adjusting and sorting them by. But yeah, there are other ways to do that. You can do a layering system, which I did, so it basically always draws certain faces before certain faces. But yes, thank you very much for watching. I'm going to be taking a break next week, because I'm going to at least try to get something done for revision. Fingers crossed. But I'm going to be returning 2 weeks from now, probably on Wednesday at the same time. I'm going to be posting the time on the Twitch page, but most likely it's going to be Wednesday 2 weeks from now, 1800. And thanks for watching, and everyone, you should all tune in to Revision Online next week from Thursday to Sunday. It's obviously going to be an online-only event this year, but it's still going to be damn awesome. And hope to see you if there's some chat involved with that. And see you all next week. I mean 2 weeks from now. Thanks for watching. Bye bye.